So with our next unit here on the polynomials, we're going to be spending a little time working with complex numbers. I'm not a big fan of the name because it makes them sound super complicated. They're not super complicated. A complex number simply involves typically a real part, so a real number like you've been working with your entire life, and an imaginary part. And I hope last year you were exposed to imaginary numbers. If you weren't, here's a brief refresher, and then we'll do some work with them. So, years and years ago, hundreds of years ago, we came across the problem of what do you do if you need to square root a negative? Because for any real number, a positive or a negative, when you square it, you end up with a positive result. So, what does it even mean to do a square root then of a number that is negative? So, we developed a new class of numbers called imaginary numbers. They're really pretty simple to work with if you can just trust that they do, in fact, work out, which I promise you they do. So here's the gist. We're going to define the square root of -1 to be the imaginary unit I. And it's a little kind of cursive-y looking I is how we typically write it. What that means is that whenever you see that I raised to the second power, well, if you square both sides of this equation, you end up with a -1 on the other side. So this is the definition of that imaginary unit, I. Square root of -1, and then when you square I to the second power, you end up with a -1 as the result. Here's how that manifests itself. So I hope I can convince you without too much trouble that the square root of 16, the principal root, is 4, because 4 to the second power is 16. When it's a -16 instead, you still end up with a 4, you just put the letter I on the end. That's really all it is. So when you square root a negative, you end up with an I in your final result. Square root of 37, well, this actually doesn't simplify at all. Square root of 37 is 6 point something, 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 something. But if you leave it as a root, it doesn't get any simpler than this. It just stays square root of 37. So when you have a square root of -37, here's what you do. Move a letter I to the front, and then remove the negative from inside. So typically a root isn't simplified if it's got a negative inside of it. So remove the negative from inside the root, which ends up being that an I outside the root. Really what we're doing is this. You're saying, hey, -37 is just -1 times 37. This becomes that I, and then the root 37 stays behind. Here's a case where you can simplify your root a little bit. So depending what you did last year in Integrated 2, you may have seen this already, but anytime you have a root, if you can split it into a perfect square factor, and then the remaining factor, what we end up with is square root of 100 is 10, square root of 2 just stays square root of 2. So that's what square root of 200 looks like if you simplify it. So square root of -200 is the same thing, but with an I in it. Now, where you put the I, it doesn't really matter, but typically we'll do it here. So after the 10, but before the root. So the letter I will typically show up right in front of the square root when you are simplifying. Now a definition, complex numbers. So everything you see here is a complex number. They typically have a real part and an imaginary part. The real part is this A, and then the imaginary part is this B with the I then on the end of it. So in this first example, the real part is 7. The imaginary part is the -2i. In the second one here, the real part is -1.6. The imaginary part is the 2/3 I. Now on this one, it's important to know there is a real part. It's just 0. And so when the real part is 0, you just typically don't write it. So this is called a pure imaginary number because it's just the imaginary part. And then this is really equivalent to that. Now you may not think of 6 as being a complex number, but it is. It just has an imaginary part of 0. And so typically then we don't write it. So this is a pure real number. With that in mind, what am I going to ask you to do? We're going to add and subtract our complex numbers. We're also going to multiply them. So adding or subtracting is the easier way. You simply combine your like terms. So negative 8 plus 7 is negative 1. 8i minus 6i is 2i. Don't make it more complicated than this. Real parts get together, imaginary parts get together. When you're dealing with subtraction, it's the same thing, but you need to be mindful of your signs. So really, it's negative 1 minus 3. And 8i minus negative 2i. Minus the negative is going to turn into a plus. So anytime there's a subtraction, be sure to change the signs of what comes in that next set of parentheses. And add them up. This is negative 4, and this is 10i. So as you're going through your practice sheet, just check them as you go. And if something isn't working out, check in with a friend or neighbor or with me. Multiplying is not too different from what you've done before with multiplying polynomials. You're going to have to FOIL it. Now, FOIL is that mnemonic that stands for front, outside, inside, last. You can also set up a grid. I think for this first one, actually, I am going to set up a grid. Let's pretend those were all nice and straight. So negative 3 minus 7i, negative 1 plus 8i. And then to fill the boxes, just multiply. So negative 1 times negative 3, negative 1 times negative 7i, negative 3 times 8i is negative 24i. And now here's the last box. This is the one that gets a little tricky. Negative 7 times 8 is negative 56, and I times I is I to the second. Here's the thing, though. When you're putting your complex numbers together, you shouldn't have an I to the second in your final answer. Here's what I mean. Let's write out what we have now. I'm going to add together these 4 boxes. So I've got the 3 plus the 7i minus the 24i minus the 56i squared. I recommend doing this. When you see I to the second is the same thing as the number negative 1. Remember, that was part of the definition of how I works. So really, this is negative 56 times negative 1. All that does is change the minus 56 to a plus 56. So anytime you see an I squared, please remove the I squared and change the sign of the number it's multiplied by. And then put your like terms together. The 3 and the 56 become 59. 7i minus 24i is going to be negative 17i. So this times that gives us 59 minus 17i. Okay, let's go again. On this one, I would like you to do a little pause and try it yourself. Remember that when you see that squared, you're really multiplying the negative 7 minus 7i times itself. So you still have to do the all 4 boxes bit. I'm going to take a look now what we got. I notice I see an I squared, so we're going to remove the I squared and change that last plus to a minus. So 49 minus 49 goes to 0. 49i plus 49i is going to be 98i. So in this case, we ended up with no real part, just imaginary parts. That's okay. That happens sometimes. Okay, and then last one here in this section. In some ways, this one's easier. In some ways, it's a little bit tougher. Now, I say tougher only because I got 3 things multiplied together. But notice there's only one binomial, meaning we don't actually have to set up a grid this time. We're just going to multiply them together and distribute. So let's start here. with the negative 7i times another I. That's going to be negative 7i to the second. And how about just for right now, I'm going to leave this one here because we haven't dealt with it yet. You know that when you see I to the second, you should eliminate it and change the sign of the number it's with. So this will become a positive 7. And just like that, the problem has now become much, much simpler. Distribute the 7 through the parentheses, so 7 times negative 3, 7 times 5i, and you're all set. So depending how much of this you have done before, if this looks familiar from last year, I think you're going to be good to go. Tear into your practice and you're all set. If this is brand new to you, I recommend taking your time as you go through the practice examples and then checking out that Khan Academy unit linked at the bottom of the unit.